We're witnessing a structural change in how users pay for AI tools, built around resource constraints, infrastructure costs, and unprecedented invoice spikes. In this week's Data Pro newsletter deep dive from April 29, we're looking at the risks these changes pose to businesses reliant on automated workflows and large-scale data pipelines. If this version's a little bit TLDR for what you're doing right now, you can head over to our YouTube page and check out a summary version of this video from the Data Pro newsletter that we mentioned. It's all there on the front page, it's easy enough to find, and while you're there, why not hit that subscribe button so you can get these updates sent to you directly.
Picture this, all right? It is, it's like 4:30 p.m. on a Friday afternoon.
Oh, the absolute worst time for anything to happen.
Literally the worst. You're sitting there in the data engineering department. The office is super quiet. The glow of your IDE is, starting to feel a little heavy on the eyes.
Just trying to get to the weekend.
Exactly. You're wrapping up the week's final pull requests. You are already thinking about dinner, maybe what you're doing on Saturday. And then, ping! An email drops into the shared infrastructure inbox.
I feel my blood pressure spiking already. I mean, I really do.
Right. Because it's from the finance department, and it's an invoice from your primary AI vendor. So you open it, and you're just expecting the usual, predictable monthly sauce fee that you already baked into your Q2 budget.
Which is how it always used to work.
Yeah, exactly. But you look at the total, and you just freeze. Because there are commas where there absolutely should not be commas.
Yeah, man.
There are zeros that make no mathematical sense based on your user count. It's basically a career-defining board-level crisis sitting right there in a PDF.
It really is. I mean, it's the ultimate modern infrastructure failure condition, right?
It's terrifying. You realize in a single instant that your entire data infrastructure budget for the whole year might have just been vaporized in 1 month of API calls.
And the truly alarming part is that right now, across the whole industry, that exact scenario is playing out in data departments everywhere. Like that Friday afternoon panic attack isn't a glitch. It is rapidly becoming the new baseline reality for enterprise architecture.
Which is exactly why we are here today. For today's deep dive, we are pulling from this truly explosive piece of reporting published over at datapro.news.
Really fantastic piece of journalism.
It really is. It's by Samuel Williams, published on April 29th, 2026. And the title just lays out the stakes perfectly. It's called The Token Reckoning. Your AI bill is about to hurt.
Such a good title. Because it is going to hurt a lot.
Yeah, it really is. So our mission today is highly focused. The era of the massive AI subsidy, that golden age where we could just pipe endless terabytes of unstructured data into these frontier models for a flat fee that is definitively over.
It is dead and buried.
Right. So today we are going to unpack exactly why your company's AI bill is suddenly skyrocketing. But more importantly, because, we know you can't just shut down your pipelines. We're going to summarize exactly how these costs can be kept in check.
Because you have to adapt. You can't just unplug everything.
Exactly. We're going to explain precisely how you, as data engineers and tech leaders, need to adapt your architecture to survive this massive shift.
And that's the critical pivot for you, the listener. It's one thing to understand the financial shock, right?
Yeah.
It's another entirely to rebuild your engineering practices to actually withstand it.
Yeah, it's a total paradigm shift.
We are looking at a fundamental rewrite of the rules of data engineering. Because the abstraction layers we've relied on for the past 3 years, they've completely hidden the true cost of compute. And that veil is finally being lifted.
Okay, let's unpack this. Because to really understand the cure, we first have to understand the disease. Let's talk about the end of what we might call the all-you-can-eat AI buffet.
I love that term. The buffet is closed, folks.
It really is. The datapro.news piece opens with this look at the sudden shift from flat rate pricing to consumption-based billing. And the fallout is just severe. They cite this Deloitte Q4 2025 analysis.
Oh yeah, those numbers were wild.
Right. They audited several large clients who had deployed these multi-agent AI systems into production. And they found these clients were suddenly staring down monthly inference bills in the tens of millions of dollars.
Tens of millions. Just think about that.
In a single month, with absolutely no relationship to the flat rate assumptions they use in their original business cases.
Which, that represents a staggering misalignment between architectural design and financial reality. When you build a business case for a new software deployment, predictability is everything. It's your bedrock.
Right. You have to know what it's going to cost.
Exactly. If you assume a fixed cost of, say, $50,000 a month for enterprise API access, you build your profit margins, your pricing models, everything around that.
And then it suddenly spikes?
Yeah. A sudden spike to $10 million doesn't just hurt the project. It actively destroys the operating margins of the entire business unit.
It's catastrophic.
It is. And we have to understand what these multi-agent systems actually are.
Yeah.
These aren't just, simple chatbots where a user types a prompt and get the fun little answer.
Right. These are massive internal pipelines. I mean, we're talking about things like automated compliance auditing, where an agent is continuously reading thousands of pages of changing regulatory documents.
Stop. Yeah.
It's extracting entities, cross-referencing them against internal company policies, generating risk reports, just massive scale.
Exactly. And in a flat rate world, engineers just didn't have to optimize those pipelines for token efficiency. They didn't care.
Because it was basically free.
Right, at the margin. They could pass the entire 100,000 token context window back and forth to the frontier model for every single little micro task.
Yeah.
Because, like you said, the perceived marginal cost of that compute was zero.
And Deloitte's analysis really shows what happens when the provider suddenly attaches a meter to that horribly inefficient architecture.
It's a bloodbath.
It really is. And Deloitte wasn't alone in seeing this. The article notes that Notion, the major productivity platform, they heavily integrated AI features into their core product. And they actually disclosed that AI infrastructure costs were consuming approximately 10% of their profit margins.
10%. For a SaaS company, that is a massive hit.
Just strictly eaten up by the underlying AI compute just to provide the features their users already expect and take for granted.
Yeah, the users aren't paying extra for that. It's just expected now.
Exactly. And those are the massive enterprise examples. But the reporting also points out how this hits smaller teams even harder because, they have zero runway to absorb a shock like that.
Oh, the startup story.
Yes. The piece mentions a tech startup that experienced a 46,000% billing increase in just 48 hours.
Which is just a horrifying number to even say out loud.
Right. And the culprit was an agentic workflow that got stuck in a context loop. We need to dissect that because it sounds like a catastrophic architectural failure. How does a context loop generate a 46,000% spike? Like, don't these systems have rate limits?
Well, you would think so, but rate limits usually cap the number of requests per minute, not the underlying token volume of those requests. That's the trap.
Oh, interesting. Okay.
To understand the context loop, you really have to look at how frameworks like LangChain construct a React agent. An agent that loops through reasoning and acting.
Okay, walk me through that.
So let's say this startup built an agent to clean up database entries. The agent is given a prompt, a set of tools, and this sort of scratchpad memory. It attempts a task, say, querying a SQL database. But it writes a malformed query, so the database naturally returns an error.
Okay, which is a standard exception. Normally, a script just fails, throws an error in the logs, and stops. It's done.
Right, exactly. But this is an autonomous agent. It is literally designed to self-correct. So the agent takes that SQL error, appends it to its scratchpad memory, and sends the whole expanded context back to the AI model.
Just to ask, hey, how do I fix this?
Exactly. But maybe the model suggests a new query, and it hallucinates a table name. Another error? That error gets appended to the memory too, and the agent loops again.
Oh, I see where this is going.
Yeah. Every single time it loops, the context window grows larger. A 2,000 token request becomes 4,000, then 10,000, then 100,000 tokens.
Because it's dragging all the past mistakes along with it.
Exactly. And because these models charge per input token, the cost of each subsequent API call is exponentially higher than the last one.
Wow.
If you don't build a hard circuit breaker into that loop, like a strict limit on iteration depth, the agent will just spin at the maximum context limit, firing dozens of requests a minute, burning thousands of dollars an hour.
Until the vendor's billing system catches up 48 hours later.
Right, and then you get the invoice of doom.
It's literally the AI equivalent of an infinite while loop. But instead of just maxing out your local CPU, it's maxing out your corporate credit card.
That's a perfect way to put it.
And the article mentions another vector for this kind of financial ruin. A single compromised API key that racked up an $82,314 invoice in just one session.
Just brutal.
Which, again, speaks to a fundamental misunderstanding of what an API key represents today. It's not just an authentication token anymore. It is a literal blank check drawn against your infrastructure budget.
It really is. I mean, if a junior developer accidentally commits that key to a public GitHub repo or leaves it exposed in client-side front-end code,
It's gone.
Yeah. Malicious actors will scrape it in seconds.
Yeah.
And they'll route their own massive inference workloads through your account.
and you foot the bill. So when you look at these incidents together, right, Deloitte's multi-million-dollar enterprise surprises, Notion's profit margin erosion, the startup's context loop, the $82,000 key leak, we have to stop viewing them as anomalies.
They absolutely aren't anomalies.
Well, it's tempting to dismiss them as edge cases or just, sloppy engineering. But they are the highly predictable, inevitable mathematical outcome of treating an incredibly expensive, highly variable resource as if it were a cheap, unlimited utility.
Exactly.
It reminds me so much of the early 2000s, back when cell phones were just starting to get robust internet access. Do you remember those stories?
Oh, the roaming charges.
Yes. People going on an international vacation, taking their brand new smartphone, and just completely not realizing that data roaming was turned on.
I had a friend who did exactly that.
Right. They'd download a couple of emails, maybe load a basic map to find a restaurant, and come home to a $5,000 phone bill because the telecom company was quietly charging them by the kilobyte in the background.
And you had no idea until the bill arrived in the mail.
Exactly. What we are seeing now in data engineering feels exactly like that, but scaled up to an enterprise level. Instead of a tourist downloading an email, it's a data pipeline processing 1 million documents. And instead of $5,000, it's $50 million.
The stakes are just astronomically higher.
But this raises a driving question for you, the listener. Why is this hitting everyone right now? Why, in the spring of 2026, is the bill suddenly coming due all at once?
That is the pivotal question of this entire deep dive. Because, look, if this were just one vendor, say OpenAI or Anthropic, deciding to change their pricing page to boost quarterly revenue, you could just migrate to a competitor, right?
Sure, you just swap the API endpoint.
Exactly. But what the DataPro.news piece details is a coordinated industry-wide withdrawal of the subsidies that made early AI adoption so commercially painless. The major frontier providers are fundamentally altering the economics of their platforms almost simultaneously.
Signaling a massive shift in the underlying market.
Precisely.
Let's track the timeline the article lays out because it paints a very clear, very deliberate picture. Google essentially started the domino effect in late 2025. They quietly cut the free tier quotas on their Gemini API by somewhere between 50 and 80%, depending on the model.
Which is a massive reduction.
Huge. And then, in April 2026, they introduced strictly enforced billing caps that hard stop your pipelines if you cross them without a pre-negotiated enterprise agreement.
The pipeline just breaks.
Yeah, it just halts. And Microsoft made their move in that exact same month, April 2026. They completely removed free Copilot chat access for any organization with over 2,000 seats, forcing these massive enterprise clients into paid per-seat tiers just to maintain the status quo.
Just to keep what they already had.
Right. And OpenAI has been publicly signaling for a while that their unlimited enterprise plans simply cannot survive contact with actual real-world usage economics. But the primary case study in the piece, the one that really serves as the canary in the coal mine for data engineers listening to this, is Anthropic.
And Anthropic is the critical focal point here for a very specific reason. Their Claude models underpin more production data pipelines than almost any other frontier provider right now.
Mostly because of the context window, right?
Yeah, massive context windows and really strong performance on extraction and coding tasks. And because they are so deeply embedded in enterprise architecture, their structural overhaul is the most consequential.
It hits the hardest.
Absolutely. For most of Anthropic's commercial life, it was a beautifully simple proposition for a tech lead. You pay a flat subscription fee, you get enterprise access to Claude, and you build your tools.
Simple, clean.
But that model is now dead. It is closed to new customers, and for existing customers, it vanishes the moment of their next contract renewal.
And what replaces it is this completely bifurcated, highly complex system. They have moved enterprise customers entirely off those flat-rate subscriptions. The new model introduces platform access fees first.
Right, the per-seat stuff.
Yeah, so if you were a technical staff, a developer, you pay $20 a month for Claude Code. If you are a standard business user, you pay $10 a month for Claude.ai. But, and this is the massive flashing red light for anyone managing a budget, those seat charges only cover access to the interface itself.
Just the UI?
Exactly, the actual usage of the AI, the compute required to process your prompts and generate responses. That is now billed entirely separately, at standard API rates. based strictly on the actual volume of tokens you consume.
What's fascinating here is the brutal, almost surgical math of how Anthropic executed this transition at the exact same time that they moved everyone to this unpredictable usage-based paper token billing model. They also completely eliminated their API volume discount.
Oh, that is so rough.
It is. Previously, larger enterprise customers running massive data pipelines enjoyed volume discounts of between 10 and 15%.
Just for doing massive volume.
Right. So look at the structural shift. The cost moved against the consumer in two directions simultaneously. You lost the safety net of a fixed-rate subscription, which exposes your architecture to infinite variable costs. And simultaneously, the per-unit cost of that variable usage went up because your volume discount was erased.
It's a double whammy. I mean, I have to be honest, when you lay out the timeline and the mechanics like that, it feels like a massive coordinated corporate cash grab.
It definitely looks like one.
It's the classic Silicon Valley playbook, right? You get everyone hooked on the product with a subsidized, artificially cheap flat rate. You make sure your API becomes the fundamental load-bearing infrastructure for their internal data pipelines. And then, once the switching costs are incredibly high and they are thoroughly locked in, you flip the switch.
Yep.
You jack up the prices, kill the discounts, mandate usage-based billing, and watch the revenue roll in. It feels inherently predatory.
It is incredibly tempting to view it through that lens, as a purely profit-driven bait and switch engineered by the finance departments at these AI labs. But if we dig deeper into the source material, the reporting makes a very compelling case that we need to aggressively correct that assumption.
Really?
Because this isn't about profit margins. It's about panic.
Panic. Okay.
It is panic over physical resources, the software pricing changes, the loss of discounts, the new billing tiers. Those are just symptoms. The disease is a hardware reality that the AI providers can simply no longer shield us from.
This brings us to the physics of pricing, which is a concept I think a lot of software engineers really struggle with. We think of AI as this ethereal thing in the cloud. It's just math, weights, and code floating in an infinite AWS instance somewhere.
But it's physical.
Very physical. It's fundamentally grounded in metal, electricity, and massive cooling systems. The Datapro.news piece drops some staggering market statistics to connect this software pricing shock directly to the hardware reality.
Yeah, the hardware numbers are sobering.
For instance, the rental prices for Blackwell GPUs, which are currently the absolute bleeding edge of AI hardware required for training and inference, spiked 48% in just 2 months.
48%? That's insane.
CoreWeave, which is a major specialized cloud provider that leases GPU compute to these AI labs, raised their prices by over 20% late last year. And the Bank of America is predicting that the sheer global demand for compute power will outstrip the physical supply of hardware all the way through 2029.
That physical bottleneck forces the AI vendors into an impossible corner. They simply cannot physically buy, rack, power, and cool enough servers to keep up with the sheer volume of unstructured data that enterprise pipelines are throwing at them right now.
They just don't have the metal.
Exactly.
Yeah.
And Williams points out how this constraint manifests not just in pricing, but in quiet operational downgrades at the platform level.
Like what?
Well, for example, in late March 2026, Anthropic started aggressively tightening the concurrent session limits for their Pro and Max users during peak hours.
So you just can't run as many tasks at once.
Right. But even more telling, and far more disruptive for data engineers, is what they did to Claude Code's prompt cache time to live. They slashed it from 1 hour down to just 5 minutes.
We really need to pause on that because that is a massive operational downgrade that completely breaks certain development workflows.
It really does.
For those listening who might not be deep in the weeds of how prompt caching actually functions at the hardware level, let's just explain it quickly. When you are doing a long coding session or running a complex pipeline, you pass a massive amount of context to the model. Maybe your entire code base or 100 pages of documentation.
Right.
The AI reads it and holds that context in a cache. That way, when you ask a follow-up question 5 minutes later, it doesn't have to reread and recompute the entire code base all over again. It just references the cache, which saves you a massive amount of tokens and makes the response nearly instant.
It's super efficient.
Yeah. Keeping that cache alive for an hour gives a developer a really smooth, continuous workflow, dropping the time to live to 5 minutes. That means if you step away to get a coffee or if your pipeline has a 10-minute delay between batches, the cache is wiped.
Just gone.
gone. When you make your next query, the AI has to reprocess the entire massive context window from absolute scratch. That burns a massive amount of your token quota and skyrockets your bill. So why would a company intentionally degrade the user experience of their premium $20 a month coding product so severely?
Because holding that cache in memory isn't free.
Okay, walk us through that.
It requires active VRAM, video RAM, on a physical GPU inside a data center. When you send a prompt, the model calculates what's called the attention matrix. It's basically how every word relates to every other word. That matrix is stored as a key value cache, or KV cache, in the GPU's high bandwidth memory.
And VRAM is expensive.
VRAM is currently the most expensive and constrained real estate on the planet. If Anthropic has 100,000 developers taking a coffee break, that is terabytes of VRAM tied up doing absolutely nothing.
Wow, just sitting there.
Just sitting there. They simply do not have enough GPUs to let your idle context sit there. They have to evict your cache to free up VRAM for another user's active inference request.
That makes so much sense.
Right. As one infrastructure analyst quoted in the piece put it, Anthropic is likely acquiring enterprise customers far faster than it can physically scale its compute capacity. The unit economics simply do not work at the old flat rates.
They're victims of their own success.
Exactly. And Anthropic CEO Dario Amodei explicitly acknowledged this tension recently. He noted that building a modern AI data center is a massive, complex physical undertaking that takes 1 to 2 years just to bring online.
You can't just spin it up overnight like a VM.
No, not at all. These companies are committing billions of dollars right now for demand they cannot actually verify will exist 2 years from now. Amodei stated directly, if you're off by a couple of years, that can be ruinous.
That quote is chilling for anyone relying on this infrastructure. Ruinous. It shows you the absolute knife edge these companies are operating on. It's not unlimited scale. It's a desperate scramble for silicon.
Exactly. And so if we connect this to the bigger picture, the repricing, the removal of enterprise discounts, the shortening of cache times, these are not pricing decisions aimed at maximizing quarterly profits. They are capacity rationing decisions.
Capacity rationing.
Yeah. The infrastructure is redlining. They are actively trying to suppress demand.
I just have to marvel at that concept. You have some of the most successful, heavily funded, hyped technology companies in human history, and they are actively restructuring their entire business models to try and discourage you from using their product too much.
Yeah, please stop using our product so much.
They are practically begging enterprise users to slow down just to keep the servers from melting. It completely flips the traditional tech growth model on its head. Usually it's all about maximizing engagement, maximizing time in app, reducing friction. Here, the friction is intentional. Please, use less of our product or we will charge you until you stop.
That's exactly it.
But knowing why they're doing this, because of this intense physical capacity constraint, we have to steer this conversation into the really insidious part of the Data Pro article. Because these vendors aren't just raising the sticker price of tokens, they are introducing these silent, invisible vectors of cost that are inflating bills right under the noses of data engineering teams who think their pipelines are optimized.
And this is where the transition from flat rate to consumption billing becomes truly dangerous for an engineering team. Because the consumption itself is largely invisible to the human eye. You aren't buying gallons of gas or gigabytes of storage. You are buying tokens and token consumption scales in ways that completely defy human intuition.
It really does. The reporting outlines 3 specific hidden ways that token usage is ballooning within enterprise architectures. And the first is what the author calls the agentic disconnect.
Oh, this is huge.
Let's break that down because this is the exact trap that caught that startup we mentioned earlier. There is a fundamental architectural difference between conversational AI and agentic AI.
Very different beasts.
Right. When you or I sit down at a web interface and chat with an LLM, asking it to write an email or brainstorm a headline, we are engaged in a conversational workflow. That interaction might use a few hundred, maybe a few thousand tokens. It's a linear transaction.
Yep.
But data engineers aren't building chatbots. They are building agentic workflows. An agentic workflow, as we discussed with the context loop, is a system that iterates. It calls external tools, writes data to memory, evaluates its own output, and self-corrects. Every single microstep in that autonomous loop consumes tokens.
Precisely. Let's say you have a multi-step data quality agent iterating across a vast document corpus to extract financial entities. It reads the document. It queries a validation database. It evaluates if the extracted entity matches a known schema.
Lots of little steps.
And if it fails, it rewrites the prompt and tries again. That agent is not consuming hundreds of tokens per session. It is consuming millions.
Millions.
Millions. And the article gives us the hard numbers on the pricing reality. At current rates for frontier models, 1 million input tokens cost roughly $5, and 1 million output tokens cost $25.
$25 for output.
Yes. The discrepancy there is super important because output generation requires significantly more compute than input processing.
Ah, okay.
When you realize that a complex agentic loop might pass the entire context history back and forth dozens of times a minute, you begin to understand the math. The flat rate economics that originally made these complex agentic workloads financially viable have been recognized as a massive vulnerability by the vendors.
And they ruthlessly closed that loophole.
And they absolutely did.
Which leads us directly to the second hidden cost vector, which honestly feels incredibly sneaky. The article calls it the tokenizer tax.
The tokenizer tax.
Yeah. If you are a data engineer, your instinct is always to upgrade to the latest, most performant model available. When Claude 3.5 or Claude 4 drops, you want your pipelines using it for better accuracy.
Of course.
But the article points out that upgrading to Anthropic's newer models means you are quietly encountering a brand new tokenizer.
And to understand why this is a tax, we really need to clarify what a tokenizer actually does under the hood. Large language models do not read English words.
They read numbers.
Exactly. They read numerical tokens. A tokenizer is the algorithm that breaks down human text into these numerical chunks based on a specific vocabulary dictionary, usually using a method like byte pair encoding.
Okay.
And different models are trained on different token dictionaries. Williams highlights a critical, entirely unannounced reality in the new architecture. The new tokenizer used in Anthropic's latest models is optimized differently, and as a result, it can consume up to 35% more tokens for the exact same text input compared to their older models.
Hold on. Let's really think about the implications of that. Text is text. Why would it use more tokens? Are they just artificially inflating the count to charge more?
Well, it's not necessarily malicious, it's a technical trade-off. If a new model is optimized to be vastly better at, say, non-English languages or highly complex mathematical formatting, the engineers have to adjust the token dictionary.
To accommodate that wider breadth.
Right. So a common English enterprise term like infrastructure or Kubernetes might have been a single token in the old dictionary. But in the new, highly multilingual dictionary, that word might be split into 3 or 4 separate tokens. The model is smarter, but it requires more numerical chunks to process the exact same English sentence.
But the financial impact of that technical trade-off is entirely borne by the user.
100%.
You migrate your massive Argo pipeline to the newer model version because you want higher retrieval accuracy. You don't change a single line of your application logic. You pass the exact same million PDF documents through the system. And suddenly, your monthly bill is 35% higher, without any explicit price increase ever being announced on the vendor's pricing page. It is a silent, invisible inflation of your compute costs. Any cost benchmarking your FinOps team did on the older model versions is instantly invalidated the absolute second you update that API endpoint.
It is a profound hidden tax.
Yeah.
And it perfectly illustrates why engineers can no longer treat the AI layer as a black box. But the third invisible vector of cost that Williams identifies is perhaps the most structurally damaging to a large enterprise.
Okay, what's that?
It's the new spending commitment trap. Under the new Anthropic enterprise rules, customers migrating off flat rate plans are forced to accept a mandatory monthly spending floor.
Oh, a floor.
Yeah. This floor is based on Anthropic's upfront estimate of what your token use will be, and you're contractually obligated to pay that dollar amount every single month, regardless of whether your actual usage reaches that estimate or not.
Here's where it gets really interesting. And frankly, this is where I have to push back hard on this vendor strategy. Because this spending commitment completely ignores the reality of how enterprise data architecture actually functions in the wild.
How so?
I've worked in these environments. Data pipelines are almost never a smooth, flat line of consistent day-over-day usage. They are spiky.
Really spiky.
Right. Think about a finance department running massive month-end batch jobs to reconcile accounts, or a retail company processing inventory data on Black Friday. For 28 days of the month, the pipeline might be relatively quiet, processing a baseline load.
Just humming along?
Yeah. Then, on days 29 and 30, it spikes massively. So if you let the vendors at your spending commitment based on your peak usage so you don't hit overages, you are going to be massively overpaying during the massive troughs the rest of the month. You are essentially paying for capacity you aren't using. But If you try to be smart and negotiate your spending commitment based on your average monthly usage, then when those massive month-end batch jobs inevitably hit, you are going to blast right through your committed floor and get slammed with massive punitive overage charges at peak rates.
That's a catch-22.
It is a brilliant no-win scenario for the customer.
If we connect this to the bigger picture, what you are describing with these spending commitments is the exact mechanism by which the industry is fundamentally changing its nature. We have to stop calling this a utility model.
Because a utility is just pay for what you use.
Right. A true utility model is like your water bill. You turn the tap on, you pay. You turn it off, you don't pay. What Anthropic and the other frontier labs are enforcing now is a capacity reservation model.
Okay.
Because of the GPU shortages we discussed, you are paying to reserve physical space on their incredibly constrained hardware, whether you use that space on a Tuesday or not.
Just to guarantee it's there.
Exactly. And fundamentally, as the reporting rightly points out, this creates a brand new, highly restrictive form of vendor lock-in.
Oh, absolutely.
Once your CTO has signed a contract committing to a massive monthly spending floor with one vendor, your engineering team loses all financial flexibility. If a cheaper, faster model comes out from a competitor next month, you can't route your workloads to it because you still have to hit your mandatory spending quota with your primary vendor anyway.
Your budget is captured.
Completely captured.
It is a brilliantly designed trap from the vendor's perspective, securing their revenue against hardware shortages. But it is an absolute minefield for the consumer. So with all these traps fully laid out, the end of the massive AI subsidy, the staggering physical hardware constraints, the recursive agentic token burns, the silent tokenizer tax, and the capacity reservation lock-in, we finally arrive at the core focus of today's deep dive. Survival.
Survival.
How do you, the listener, the data engineer, the technical product manager, actually adapt to this? How can you ensure your costs are kept in check so that you don't receive one of those Friday afternoon invoices of doom?
This is where we transition from admiring the problem to executing the solution. The DataPro.news piece does an excellent job of synthesizing a specific, actionable survival guide for data engineers facing this reckoning.
Yes, it lays out 5 specific steps.
It outlines 5 critical architectural and operational steps that must be taken immediately to adapt to this new reality. And the very first step is foundational, but surprisingly rare in practice. You must instrument consumption.
You cannot manage what you do not measure. It is an old business cliche, but it has never been more vital than it is right now with token economics.
Not at all.
The author makes it clear. You have to move away from blind API calls. Just looking at your total monthly AWS or Anthropic bill at the end of the month and trying to guess which department or which pipeline spent well is a recipe for disaster.
You'll never figure it out.
You need per pipeline, per workflow token visibility. If you have a customer support entity extraction pipeline running in production and a separate internal document summarization pipeline for the legal team, you need a telemetry dashboard that shows you exactly how many tokens each specific workflow is burning in real time.
In real time, that's the key.
But practically speaking, how does an engineering team actually build that? You can't just ask the API to categorize it for you.
No, you have to build middleware to intercept and log the telemetry. When your application makes a call to the LLM, the API response includes metadata in the headers detailing the exact input and output token count used for that specific request. Your architecture must capture those headers before passing the response back to the application.
So you grab the receipt before the user sees it.
Exactly. You need to tag every single request with a unique identifier, say pipeline, legal summarization, or agent.db cleanup, and stream that telemetry into an observability platform like Datadog, or use specialized AI observability tools like Langsmith.
Just giving yourself actual vision into what's happening.
Right. If an agentic loop starts spinning out of control and its token burn rate deviates from the historical baseline by 20%, you need an automated alert to fire and slack the moment it happens. And you need a circuit breaker to automatically sever the API connection. You cannot wait 30 days for the invoice to arrive to realize you had a leak.
Without that granular instrumentation, you are flying completely blind into a metered billing environment, which leads directly to the second step of adaptation, recost and stress test.
This one is painful but necessary.
It is. If you built a data pipeline, say, an automated support ticket classifier back in 2024 or 2025 using flat rate subscription economics or older token pricing, your cost model is a fiction.
A total fantasy.
It no longer reflects reality. You have to go back to the drawing board and re-benchmark every single AI-dependent pipeline at current usage-based token rates, accounting for the tokenizer tax we just discussed.
And it isn't just about finding the current baseline cost. The article specifically advises engineers to aggressively stress test these cost models using Monte Carlo simulations or historical load testing.
Meaning you can't just assume an average.
Exactly. You cannot assume an average token length for user inputs. You have to simulate the long tail. What happens to your infrastructure budget if that pipeline has to process 3 times its normal volume during a seasonal spike? Then you need to simulate what happens at 10 times its normal volume.
The 3x and 10x tests.
Yes, that 3x and 10x stress test needs to become your baseline planning assumption. It sounds paranoid, but as the reporting points out, it isn't pessimism. It is basic data stewardship applied to your own operating margins. You need to know exactly at what volume of data your AI pipeline mathematically becomes more expensive than the business problem it's trying to solve.
Right, because the unit economics of the solution cannot exceed the value of the outcome. If it costs $2 to automatically classify a support ticket that a human could classify for $1.50, the AI pipeline is actively destroying value no matter how technologically impressive it is.
It's just bad business.
Exactly. Now, step 3 addresses the human and organizational element of this crisis. Assign FinOps ownership. FinOps financial operations has to become a core engineering priority, not just a finance department afterthought.
It's so true.
The author asks a very blunt question. Who in your organization specifically owns AI spend governance? If the answer is everyone, or the engineering managers generally, or if you just aren't sure, your architecture is in immediate danger. The usage-based billing model is ruthless, and it will exploit any gap in ownership.
Exactly. Someone specific, with a name and a title, must be responsible for monitoring those instrumented dashboards, authorizing version upgrades that might trigger a tokenizer tax, and negotiating those dangerous spending commitments.
A single point of accountability.
Yes, and crucially, that person must have the engineering authority to pull the plug on a pipeline if the unit economics invert. If FinOps is just a reporting function with no authority over architecture, it is completely useless.
It is the only way to establish real accountability. Now, step 4 is where we get into the pure architectural adaptation, and this is where engineers need to pay close attention. Abstract dependencies.
Oh, this is the good stuff.
If your entire codebase is littered with direct, hard-coded REST API calls to Anthropic's Claude or OpenAI's GPT-4, you are entirely at their mercy when they change their pricing, their rate limits, or their tokenizers.
You're trapped.
You are entirely locked in. The article insists that engineers must rebuild their pipelines using model-agnostic interfaces. We are talking about utilizing orchestration frameworks like LangChain, Llama Index, or building your own custom internal routing layers.
Right.
The goal is simple. Your core application logic should not have to be rewritten just because you decide to switch AI providers. If vendor A jacks up their prices on a Tuesday, or if their GPUs go down, your abstraction layer should allow you to seamlessly route your background extraction tasks to vendor B on Wednesday, just by changing an environment variable without deploying a massive code rewrite.
That abstraction layer is your absolute shield against vendor lock-in. But I want to push on how this actually functions in a production environment, because it's not as simple as just swapping a URL.
Right, because the prompts act differently.
Exactly. Different models require different prompt engineering to get the exact same results. So the true architectural adaptation here is building what we call a fallback model cascade, or semantic routing.
How does that work?
Your routing layer shouldn't just send everything to the most expensive model. You write logic that says, for this specific task, first try querying a fast, cheap model. If that model returns a result with a high confidence score, or if the output perfectly matches the required JSON schema, just use it.
And if it fails?
If the cheap model fails, or the confidence is low, only then does the router kick the prompt up the cascade to the expensive, heavy-duty frontier model. This ensures you are only paying premium token prices for complex reasoning, not for basic text formatting.
That is brilliant. You are matching the compute cost to the complexity of the task dynamically. But that abstraction layer and that fallback cascade only work if you actually have viable, cheaper alternatives to route to. Which brings us to the 5th, final, and arguably most critical adaptation step in the survival guide. What the reporting calls the open weight hedge. This is the ultimate survival tactic for an enterprise data team.
This is the most empowering shift in the entire landscape right now. The author is not saying you should abandon frontier models entirely. There are always going to be incredibly complex reasoning tasks, deep coding challenges, or massive context window that require the absolute cutting-edge, massive models locked behind vendor APIs.
Right, you still need the heavy lifters.
But he argues vehemently that you absolutely must build the internal infrastructure and the operational muscle to utilize open weight models. We are talking about models whose weights are freely available to download and run, like Meta's Llama 3 family, Mistral, or Qwen.
Let's spend some time on this because I know there's still a lot of skepticism among tech leads about this. I hear it all the time. They say, I've tried deploying a small Llama model locally to extract JSON, and it hallucinated the schema half the time. It missed commas. It broke the pipeline. Are we really saying these open weight models are actually production ready for enterprise pipelines, or is that just academic benchmark hype?
It is a totally valid concern, but the perception of open weight models needs to shift drastically. The landscape has changed. These are not toy projects or theoretical alternatives anymore. As the article states, the latest generations are highly capable production-grade models.
They've caught up.
They have. And more importantly, the ecosystem around them has matured. If you are struggling with JSON hallucinations, you don't just rely on the model's raw output anymore. You use structural enforcement tools.
Like what?
Libraries like Outlines or native JSON modes and inference engines like VLLM. These tools basically force the open weight model to only generate tokens that adhere strictly to your predefined database schema.
Oh, so it physically can't hallucinate a bad format.
Exactly. By constraining the generation path, you eliminate the formatting hallucinations. When you apply those techniques, open weight models become incredibly reliable for specific, high-volume, pipeline-scale tasks. Things like classifying incoming text, extracting named entities, generating structured JSON data, summarizing internal documents.
The grunt work.
Yes. For those specific jobs, they are already highly competitive with the expensive frontier models.
But here is the absolute magic phrase for a data engineer trying to keep costs in check. 0 per token pricing.
Music to my ears.
Because the model weights are open and available, you aren't paying a vendor a toll for every single word it reads or writes. You aren't paying a 35% tokenizer tax. You aren't paying a 5x premium for output tokens over input tokens.
It's just yours to run.
Now, obviously, you do have to pay for the compute to run it. Inference is not free. You can run them on-premise if your company actually owns the server hardware. You can run them on reserved cloud instances using engines like VLLM with continuous batching to maximize throughput. Or, as the Data Pro article suggests, you can use specialized inference providers like Together, Fireworks, or Grok.
Grok is fascinating.
Yeah, I want to highlight Grok specifically because they use specialized LPUs language processing units instead of traditional GPUs, which allows them to offer vastly cheaper, incredibly fast compute costs compared to the primary frontier vendors.
It's a game changer for inference speed.
It really is. To put this entire strategy in perspective, abstracting your dependencies and building out this open weight infrastructure is exactly like ensuring your house is wired to run on a generic, reliable, heavy-duty generator.
Oh, that's a great analogy.
Sure, most of the time you might draw power from the massive, wildly expensive private power grid because it's convenient and it can handle massive spikes. But the moment that private grid decides to quadruple its prices, eliminate your discounts, or implement rolling blackouts because they are rationing their GPU capacity, you aren't left in the dark.
Nope.
You just flip a switch in your routing layer, fire up your open weight generator, and keep your essential data pipelines running without missing a single beat. The open weight models are your generator. They are your ultimate hedge against the commercial chaos of the AI market.
This raises a critical organizational question, though. Are enterprises actually willing to put in the hard engineering effort required to build and maintain that generator? Because utilizing open weight models requires a very different set of engineering muscles than simply pinging a REST API and letting Anthropic handle all the infrastructure.
True, it's not plug and play.
It requires understanding containerized deployment, model hosting, KV cache memory management, and infrastructure orchestration. It's real engineering work.
Yeah, you have to get your hands dirty.
But as the reporting concludes, this is the new reality. Token economics are no longer an afterthought that you can just ignore while you build cool features. Managing the cost of compute is no longer just a finance problem. Token economics are now a core engineering discipline.
Wow.
It is as fundamental to modern software development as managing memory leaks in C++ or optimizing query execution plans in a massive SQL database.
Yeah.
If you don't understand how to optimize it, your code is functionally broken.
So what happens to the companies that just plug their ears and ignore these 5 steps, the ones who don't instrument, don't abstract, and just keep building their architecture exactly how they built it in the subsidized days of 2024?
Well, the piece is incredibly clear and frankly ruthless on their fate. The companies that fail to instrument their token consumption, that fail to stress test their cost models against peak loads, and that fail to establish clear FinOps ownership with actual architectural authority will discover the new economics of AI exactly the way Deloitte's clients and that startup did. Suddenly, painfully, and at a scale that actively threatens their commercial viability.
Because the safety net is gone.
The massive AI subsidy of the last 3 years was a temporary, venture-backed phenomenon designed entirely to drive rapid enterprise adoption. It worked perfectly, we adopted it, we built our pipelines around it, and now the bill is coming due.
It's time to pay up.
The industry is rapidly maturing, and the most painful part of that maturation process is forcing the true physical cost of massive GPU compute back onto the consumer.
So what does this all mean? Let's bring all these complex threads together for the listener. Today, we've seen that the golden era of cheap, flat rate, all-you-can-eat AI access is definitively over.
Rest in peace.
The major vendors, Google, Microsoft, OpenAI, and most notably Anthropic, are facing a brutal, unavoidable reality of physical hardware constraints. They physically cannot build data centers fast enough to keep up with enterprise demand, so they are actively rationing their capacity through aggressive pricing restructures, the elimination of enterprise volume discounts, and the enforcement of mandatory spending commitments that lock you in.
It's rationing by price.
We've learned that this shift exposes engineering teams to ruinous, often invisible costs. Unmonitored agentic workflows can burn millions of tokens in minutes by entering context loops, generating massive invoices overnight. Upgrading to newer, smarter models exposes you to the silent tokenizer tax, quietly inflating your usage by up to 35% without a single change to your code.
Terrifying.
And committing to high spending floors traps you into paying for peak capacity you might not even use during your normal operating days. But, crucially, we also unpacked the survival guide. We prove that costs can be kept in check and data engineers can adapt to this new reality.
There is a way out.
By treating financial operations, FinOps, as a core engineering competency with real authority. By instrumenting every single workflow to measure and alert on token consumption in real time. By aggressively abstracting your AI dependencies behind agnostic routers and building fallback cascades, and most importantly, by embracing the open weight hedge, building the internal infrastructure to run highly capable zero-token cost models like Llama and Mistral for your everyday, high-volume pipeline tasks.
Ultimately, building production AI workloads under the old flat rate assumptions is a relic of the past. The vendors have already made the decision to transition to a rigorous, physically constrained, metered reality. The only variable left in this equation is whether your organization will proactively build the architecture to manage it or reactively scramble when the infrastructure budget collapses on a Friday afternoon.
Which brings us to a final thought for you to mull over as we wrap up. We've spent this entire deep dive talking about how to manage the massive costs of AI compute, how to route around it, how to monitor it, and how to optimize it.
Right.
But if token economics and compute scarcity are now the defining, unavoidable constraints of modern data architecture, will the most valuable, highly compensated data engineers of the future be the ones who can build the most dazzling, complex, multi-agent AI workflows? Or will the true rock stars of the next decade be the engineers who figure out how to do the exact same job, achieving the exact same business outcome, using a clever algorithm, a well-structured database, and no AI at all?
That is the real question.
Think about that the next time you are sitting at your desk, staring at your inbox, wondering what your infrastructure invoice is going to look like. Keep your pipelines efficient, keep your abstractions flexible, and keep your APIs strictly monitored. We will see you on the next deep dive.
Thanks for checking this out today. Don't forget you can connect with other data professionals worldwide on our growing school platform. It's all linked in the description, so pop along, come in, have a chat, and check out the exclusive resources there for data professionals like you. And if you haven't done so already, please feel free to like, share, or subscribe to the channel.